We want to solve the following problem using calculus techniques. We want to determine the number of units, x, needed to be made and sold to maximize the profit, which is P of x in dollars, given the revenue and cost functions. We also want to know what is the maximum profit. So the first thing we have to remember here is that the profit is going to be equal to the revenue function minus the cost function. So P of x is going to be equal to the revenue function, which is 60x minus 0.5x squared minus the cost function, which is the quantity 3x plus 8. Remember, it's important that we put the cost function in parentheses so that we subtract this entire function, not just 3x. Let's go ahead and simplify this. Here we can just drop the parentheses. Here, we want to subtract both terms or think of distributing a negative 1. So we'd have minus 3x minus 8. Notice how we have two x terms. Let's go ahead and combine them. I'm also going to put the terms in descending order. So I'll put the squared term first. And then 60x minus 3x is 57x, so plus 57x minus 8. Now to review, if we want to maximize the profit using calculus techniques, we want to first determine the critical numbers, which occur where the derivative of this function is either undefined or equal to 0. So now let's find the derivative. P prime of x is going to be equal to, here we'll apply the power rule, so multiply by 2 and then subtract 1 from the exponent. That's just going to be negative 1x, or just negative x. The derivative of 57x would just be 57. The derivative of negative 8 would be 0. Notice how this derivative is never going to be undefined, so let's set it equal to 0 and solve for x. So this equation here is pretty straightforward to solve. We would add x to both sides of the equation. We would have 57 equals x. Now I want to take a moment and go back and take a look at this function here. Notice if we were to graph this, this would be a parabola that opened down because a, the coefficient of x squared, is negative. So if we have a parabola that opens down, and we're trying to maximize this function, this high point here would represent the maximum. And notice that at this point here, or the vertex, the slope of the tangent line would be 0, which means the derivative would be equal to 0 at this high point. The reason this is helpful is we now know that at x equals 57, we do have the maximum profit. But remember, x is the number of units, so to maximize the profit, they would need to make and sell 57 items, or units. Now we want to determine the maximum profit, which occurs when x equals 57, so the maximum profit would be equal to P of 57. So using one of these forms of the profit function, we'll substitute 57 for x. Let's go ahead and use this form here. So we'd have negative 0.5 times 57 squared plus 57 times 57, and then minus 8. And I've already evaluated this to save some time. This comes out to $1,616.50. And now we've answered both questions. I hope you found this helpful.